Well, the high-performance computing of the past was focused on certain classes of problems associated with uniform meshes, and that's going away. I mean, so the unstructured mesh, the social computation, the contribution of high-performance computing to biological and social problems, this is the future as regards the kind of problems we're talking about here at this conference. And so the future of it is to make it ever more possible to integrate all the different components of the systems that need to be connected for things like pandemics, but also banking systems and stuff, all the details, the social details and physical details, technical details that combine to make these systems, it really can't be done. The interdisciplinary project can't be undertaken without high performance computing, just to compute just the volume of interactions that go on in these systems. If you look at the impact of things like, say, Google, or even more Facebook, say, nobody designed Facebook from scientific first principles, but Facebook in its use has driven a whole bunch of social science, right? And computational capabilities have both been motivated by and used by things like Facebook and other social media. So the global system science questions take, they're complexity science style questions. They say this is a first class question to ask how all this stuff is connected to all this stuff. Whereas in the past, science said it's not a legitimate question. You have to ask this narrow sort of stovepiped questions, right? But now it's legitimate to ask these big questions, to say how is the atmosphere connected to individual purchasing behavior of something, right? Or where you choose to live and so on. These kinds of connections on the scale of the population of the Earth being viewed as first-class questions don't fit very well on first generation, second generation, third generation HPC, but they will, by asking them, they will shape the science and the platforms that science depends on to answer those questions. And so the evolution of HPC is very much a coevolution system itself with these questions, right? So that's the first part of my answer to that question. The second part, though, is that because of the pervasiveness of computing in our pockets and the Internet of Things and all the things we talk about, and just the scale and scope of the capabilities that are pervasive, those have to be included for many different reasons into extreme scale computing, because it's just happening everywhere. The computing is happening all around us, and so that the centers and the increased number of centers that actually have what we would call HPC resources, these kinds of things are needed to just coordinate and tie together all this information. So between these two things, I mean, it's a revolution in computing. It's just the injection of computing and communication into everything around us. And at the same time, the dealing with the just massive amount of data and the complexity of the systems we're asking questions about will drive high performance computing, and that will in turn enable more of these questions. It's just completely coupled in global system science and high performance computing. The socio-technical evolution with respect to things like transportation, okay, say, has more people traveling, the price point, and farther, right? This is combined with the globalization and the change in average income of individuals, more and more individuals around the world. There are just more people traveling. There's more connectivity among people. There's more connectivity among crops that are being moved around. So these pandemics are not just about people. It's about tomato pests and wheat diseases and the invasion of GMO crops from one continent to another crop through seeds transfer and so on. There's all kinds of connectivity that leads to epidemic-style systems that are increased because of the modern world. And so increasingly these issues are also a matter for policy, they're a matter for decision makers, they're a matter for consideration, and they have to be studied. And so that if all you look at are the pandemic style diseases themselves, just diseases, plant diseases, human diseases, zoonotic diseases, they're not going to get easier because of the way the world's interconnected. But the kind of diseases, the kind of, not just diseases, the kind of effects in systems that have to do with not just the migration of people and things, but the migration of ideas and the migration of behaviors and other things around, those also are of deep concern right now. I mean, politically, socially, all kinds of things are connected in ways that pandemic-style studies inform and help us learn about, and the coevolution of those studies with this computing capability is it's a watershed in the computational and scientific world to be able to incorporate these sort of human level issues into what is viewed as science. And global system science and high performance computing are central to that.